Okay, good morning everyone. What I'd like to do is continue the discussion on development of the array object from what we covered last time. So if you recall, the main objective was to develop an array object that is convenient to use, sort of similar to list arrays of Java. They're dynamic in size. We can grow them, shrink them as we want, and overcome some of the limitations of the primitive arrays that are in C++. So to that end, we had declared this particular approach, an array object, which contains very little. So just to review it, it has a default constructor that when invoked, it will set the size of the object, the size to be 10 elements, allocates appropriate amount of space, and then walks through the elements of the array and initializes them to 0. It had a default an alternate constructor where the user must specify the size of the array and may or may not specify the initial values of the array. So that particular function works very similar to the default constructor. However, the size of the array is specified by the user. The size will be set to what has been passed. Appropriate amount of space is allocated. And then elements of the array are looped and set to the value that has been passed by the user, and if not, default value of -10 has been used. -10 from here, the default value. Copy constructor, which we're going to skip for now. The destructor, which is kind of unique concept to C++. The only thing at this point this destructor does is to clean after itself by deallocating the space that was reserved for the by the pointer data. Then I have a couple of auxiliary procedures, methods, one of them called print that essentially loops through the elements of the array and prints it onto the screen. And getIndex was a demonstration of where now we can check for array out of bounds, and in order to intervene and perform the correct action. So in this particular case, without complicating everything, what I'm just doing, I'm just echoing to the screen that array index was out of bounds. So if it is larger or equal to size, or if the index is negative, you will receive a notice on the screen on the standard out says not a valid index, and a return value of -1 is issued. This is, of course, not a good approach. What you want to do, you want to take the appropriate actions of notifying the user that index is out of bound and return a null or take exception handling. If the index is a valid one, then the appropriate data item has been returned. Now, what I want to do at this point, I want to be able to perform the following function. I want to be able to copy array 2, its contents, onto array 1. So if you recall, in this particular exercise, array 1, because it is invoking the default constructor, it's going to have a size 10 and the contents of 0. Array 2 is going to be of size 5 with the contents of -2. So if I was, this portion is left over from last time where I am demonstrating get. So maybe I should do that. This particular one needs to become a comment. Toggle comment is here somewhere. Control/, okay. And so if I was to run it, you would see that at this point I get 2 indications that my index is out of bound. So I want to complete this one. Now, so in here, basically, what I want to do, I want to create a method that will receive one object and copy it to the current object. To follow that train of execution, in this particular instance, array 1 is going to be doing the calling, and array 2 is the argument that's going to be passed on to array 1 in order to duplicate it over to its own content. So the footprint of this particular method is going to be a void. For now, we're going to return nothing. It's called copy. Here I have choices. I can either pass the object right-hand side, I'm going to call it right-hand side for now, is I can call this by value, where the copy of right-hand side is created and passed on to the method copy, or I can call it by reference. And if you recall from some of the basic discussions of functions in C++, there were advantages and disadvantages to each. So when you are calling it by value, you are costing the duplication of the object that may cost time in duplication and also memory space. So that may not be a desirable thing. When you call by reference, the problem is that object right-hand side within the copy method is then vulnerable, and it can be potentially altered, mutated, and destroyed. To prevent from that from happening, we can qualify it as a constant object, which can be passed as reference, but it cannot be then altered, which is the ideal scenario because it has all the time and cost benefits of the call by reference, but at the same time it has the security of the call by value. Nothing's going to be changed. So the point is that if you do this, numerous compilation issues may arise for now until the object is fully matured. So you can't do that. And also, call by value is not an option. You will see why in the future lectures, because at this point the object does not know how it should duplicate itself. So the only option going forward is to call by reference and not declare it as a constant. So now that the object has been declared, I'm going to define it. It is of type void belonging to the object array called copy, and it is called by reference. So the very first thing that I want to do is set the size of the current object. Actually, the very first thing that I would like to do is to make sure that I am cleaning after myself. The previous object, array1's data, was pointing to an array chunk of 10 elements of type integer and was all populated with 0. So the first thing that I need to do is deallocate that space. Set the size of the current object to be equal to right-hand side dot size, and then followed by allocate appropriate space by by saying data equals new int size. Loop through the elements of the array and set data I equals right-hand side dot data I. So this is something that would probably, you would be compelled to implement something like this, although it's okay for now. It is not exactly the best way to go for numerous reasons. Some of them you know, some of them you don't know yet. I'm not sure why it's not accepting what I have there. Void copy array, right-hand side. Not sure what's going on. The problem will reveal itself as we go along. So if I was to continue to comment, first, you should never directly access the contents of a data member, and you should never set the values of member data directly. You should always go through getters and setters. I don't have them right now, but if I was, I would say set size to be right-hand side dot get size. It would be something of this form. And in this particular case here as well, set data element I at index, and you want to say right-hand side dot get data. So it would be of this sort if you were to go through formal getters and setters. But for now, I'm just going to focus on simple things and develop the object as we go along. So in here now, everything is done. Let me just go ahead and compile run. That is the culprit. By the way, so if you go back and look now, everything is clean. So if you run it, you will see that before, and let me actually comment all of these. Oops. Is it all this? So shift this. Slash, control slash. Oh yeah. So prior, as the objects are instantiated, initiated, they will be, array 1 would be of size 10, all zeros. Array 2 would be 5 elements of all negative 20s. And after the execution of the copy method, both objects are of size 5 with the contents of negative 20. Array 2 has been copied over to array 1. Now, of course, if I was to complete this, I would run Valgrind to make sure that I have no memory leaks on this program. So this is going to conclude some of the topics that you guys need for your next assignment in how to actually receive an object to use that in order to modify the current object. So the next assignment, for the next lecture, I am going to focus on copy constructor and why we even need to have a copy constructor in place. So thank you, and I will talk to you later.